going to talk about different types of pairs of lines and angles. So the first types of pairs of lines we have are what we call parallel lines. What do we know about parallel lines? Yeah, so there are two lines that do not intersect and are coplanar. What does coplanar mean again? Lie on the same plane. Okay, so take a look around the room. Let's try to find some examples of parallel lines. What are some examples of some parallel lines in this room? The floor, okay, so the ones like, yeah, the tile that don't, so like this set of lines, good. How about on the ceiling tiles? This line would be parallel to that line, right? The top of the whiteboard and the bottom of the whiteboard, would those be parallel lines? Yeah, okay. How about if I said, okay, so you guys see like the indented lines, the picture frame lines? Let's do this side. Well, no, I guess, yeah. So that side line, would that side line be parallel to the same indented line for the picture hanging thing? Would those be parallel? Yeah, if they measured them correctly. Even if they were a little off, they would still probably be parallel because we could officially put a plane between them, right? Okay, so let's think about this. For them to be in the same plane, what needs to be true about the parallel lines? They need to be going in like the same direction, right? Because couldn't I, if I focused on this strip right here in the ceiling, couldn't I take a strip of tape and make a line that's going directly below it and make that also be parallel, right? Okay, so parallel lines need to be going in the same direction. They need to be in the same plane, and they never will intersect. Okay? And the reason why I'm really talking about going in the same direction is because what we get to next is what we call skewed lines, which is a little bit different. So skew lines are two lines that do not intersect. So that's the same thing we wrote for parallel lines. But the difference between parallel and skew is skew lines are not coplanar. Okay? So skew lines are not coplanar. So now let's think about this. I'll use my pens because that might be easier to see. Right now we're parallel, right? Parallel lines, my pens, are they still parallel? Are they still parallel? Are they still parallel? Okay, so parallel lines are going the same direction, never going to intersect. Am I still parallel? Am I still parallel? No, they're not. Are they ever going to intersect? This will never intersect, right? Because this one's shooting across, this one's shooting that direction. They're never going to intersect. Well, if we just say that parallel lines are lines that never intersect, then I would say that these are parallel lines, but they're not. They don't lie in the same plane. There's no way for me to put a piece of paper, like if I had them parallel, there's my plane. If I go like this, now, I can't get that piece of paper to lay flat on those both lines. So skew lines are lines that never intersect, but notice they're going in opposite directions. The blue pen's going front to back, the black pen's going side to side. Do you see the difference? Parallel, front, back, front to back, front to back. Skew, opposite directions. Okay, we got the difference between the two? Okay, so we had parallel lines with skew lines. Now let's talk about parallel planes. Parallel planes are two planes that do not intersect. So parallel planes are two planes that do not intersect. So if I think about this box, which plane would be parallel to the top of the box? The bottom, right? Which plane would be parallel to the side of the box? the other side. Right? So those are my parallel planes. If I think about a line shooting off this edge of the box, it would also be parallel to this edge, right? Would this edge also be parallel to the first edge? Yes. Would this edge be parallel to the first edge? Yes, because it's going in the same direction. They're never intersecting. Which edge would be skewed to this top right edge? Sorry, here so you can see.
Side.
So here we go. Would this edge be skew?
Absolutely.
Yes, because notice it's going in opposite directions, but would these two lines ever intersect? No. Would this edge up front be skew? No, because they do intersect, right? This edge and this edge do intersect. So using that, let's look at this diagram here and see if we can pull it apart from an actual three-dimensional figure. So think of each segment in the figure as part of a line. Which line or lines or planes in the figure appear to fit the description? All right, so lines parallel to line AB. So line AB is this red line shown. And I want to talk about all the lines that are parallel that contain point D. Well, what other edge is parallel to AB that contains this point? DC. Right here, right? Wouldn't that end up being parallel to it? So let's say line DC. Are there any other lines that would be parallel? Would HD be parallel? Nope, because it doesn't go in the same direction. Would DG be parallel? Nope, because it does not go in the same direction. So that's our only answer for A. Let's go to B. B is looking for all lines that are skew to AB and contain point D. Someone give me one. DH would work. Line DH. So that's going straight up and down. It's going in the opposite direction. So AB is going front to back. DH is going up and down. They'll never intersect. Give me another one. DG. Good. The DG would be skew. It's never going to intersect. And it's not parallel because it's going in the opposite direction. Any other ones? Well, we're sticking with DA. Yeah, AD would be actually intersecting it. Right? Okay. Next one. All lines that are perpendicular to AB and contain point D. Let's assume our box is square. So which would be the perpendicular line? Wouldn't it be A? D would be perpendicular. Good. All right. Did we miss another skew? Would DE be skewed? Yeah, I think we did. Can we add DE to part B? Yeah, we missed DE for skewed. All right. So far with that. Good? All right, so for D, what planes are going to be parallel to plane EFG? All right, so plane EFG, where is that on the box? EFG is on the bottom, right? So we're talking bottom plane. So which plane would be parallel to the bottom? The top, right? So we could say plane ABC, that would work. Remember, we use 3 points to name a plane, so we have 4 points in that plane, so any combination of 3. It could have also said plane ADC or plane BCD would have also worked. All right, we're good with that? So we've got parallel and skew. We know the difference between the two. Okay, so now on the back, we're going to talk about a specific type of line, which is called a transversal. A transversal is a line that intersects 2 or more coplanar lines at different points. So a transversal is a line that intersects two or more coplanar lines at two different points. You don't have to put this in your notes because you have examples up there. So just really quickly, just watch. So here I have two lines. Do they both lie on the same plane? Yes, they do. The plane is the board itself, right? A transversal is any line that intersects both those lines. So this yellow line would be a transversal. 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 Okay? So a transversal is a line that intersects two or more coplanar lines at different points. I could add a third line in there that intersects. So now that transversal is intersecting three different lines at three different points. So when that occurs, we get a bunch of different angle relationships. So our first angle relationship is corresponding angles. So squeeze it in there in that white space underneath corresponding angles. Corresponding angles are two angles. And again, make sure you can feel free to use abbreviations. So two angles having corresponding positions. So here I have angle 1 and angle 5. Those would be corresponding angles. Go ahead and label 1 and 5 on the actual diagram that you have there. All right, so now let's look around the room. Nathan, Lily, and Megan are in corresponding positions. What does that mean? So I'm telling you right now that Nathan, Lily, and Megan are in corresponding positions. What, Connor? What does that mean? Put a definition to it. Nathan, Lily, and Megan are in corresponding positions. Look at the desk arrangements. So we're in groups of 4, right? So right now Nathan's sitting in, let's say, the left, if I use my left front. Is Lily also in left front? If I stand here, left front. If I stand here, Megan is in left front. Is there anybody in this group at left front? No. Is there anybody here in left front? No. So those 3 guys are the only ones that are in corresponding positions. Does that make sense? So corresponding means that they're in kind of in the exact place. If I was looking at this angle up here, just watch, don't mark. This angle would have a corresponding angle where? So this is top left, this is top right. If I go down here, where's the top right? Right there. You see it? If I go bottom right would be corresponding. If I go, let's get another color in there, bottom left would be corresponding with bottom left. It's making me think about Twister right now. Okay, so corresponding, you got the idea? So corresponding, same position. So if you look at this intersection of your line and the transversal, you have upper left, upper right, lower left. If you go down to the same intersection of line and transversal, you have upper left, right, lower left. So when you find these angle pair relationships, you're going from 1 up here at this intersection and comparing it to 1 down here at this intersection. Got it? Okay, so the next one we have is alternate interior. Again, abbreviate. I know I don't give you a whole lot of space in there. So 2 angles that lie between the two lines and on opposite sides of the transversal. So two angles that lie between the two lines and on opposite sides of the transversal. So go ahead and mark 4 and 5 on your diagram. Again, I realize I think your lines are squeezing in here as opposed to up there. So alternate. If you think about alternating, you're on either side. So alternate interior. Now let's think about this. Here are my two lines. The interior of those two lines is that shaded region, right? Interior, do a different color. Exterior would be out here. See the difference between the two? Interior, exterior. So for me to have alternate interior angles, I need my angles to be in the interior, so in between the two lines, but on opposite sides of the transversal. So 4 and 5 right now would be alternate interior angles. If I look at a different set of angles, here I have an interior angle. The alternate interior of that would be over there. Okay, so interior, inside, alternate. So corresponding, you have 4 different positions you can pick. Alternate interior, you only have 2 because you only have 2 sets of interior angles. Got that? Okay, so our next one is alternate exterior. So alternate exterior, it's going to be the same thing that you wrote before, but instead of inside, we're outside. So 2 angles that lie outside the 2 lines and on opposite sides of the transversal. So 2 angles that lie on the outside of the 2 lines and on opposite sides of the transversal. So here we have angle 1 and angle 8 would be your example of alternate interior. So again, remember we had our interior was in here and our exterior was on the outside. And if I need to be on alternate side, so angle 1 is on the exterior. The other exterior angle that we have is over here. So alternate, so here's our transversal. If I go down here, here are my other 2 exterior angles. 1 and 8 would be on alternate sides. Yellow dot and yellow dot would be on alternate sides. So alternate exterior. Again, you only have 2 options for alternate exterior. So if you're asked to name all pairs of alternate exterior angles, you only will come up with 2. If you're asked to name all pairs of alternate interior, you're only going to come up with 2. Corresponding, you can name 4. 1, 1, 2, 3, 4. All right, and then the last one is, oops, come back, consecutive interior. So consecutive interior are 2 angles that lie between the 2 lines and on the same side of the transversal. So alternate interior and consecutive interior both are interior angles, but the difference between alternate, so I need them to be on opposite sides, consecutive, they need to be on the same side. If you think about consecutive numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are consecutive numbers. They're right next to each other. So the same thing applies for interior. So if these are my two lines, this is the interior. How many sets do you have on the interior? Up here you have 2. Down here you have 2. Which ones are on the same side? 4 and 6 are on the same side and in the interior, right? If I went to the other side, then my consecutive interior would be here and here. Okay? So again, corresponding, you'll have 4 pairs. All the rest you only will have 2 pairs. So let's see if we've got this. So looking at this diagram, let's see if we can identify all the pairs that are given. So give me a set of corresponding angles. So here you have one intersection of your line and transversal. So notice my transversal is the line I just made as red. Okay, and here I have another intersection. So to make a pair, I need to pick one from the left, one from the right. Someone give me one pair. So you got one from here, now pick one from here. So one would correspond with 5. Good, because upper left. So angle 1 and angle 5 would be one set. What would correspond with 2? Good, so angle 2 and angle 6 would be corresponding. Upper right. What would correspond with 3? 7. So angle 3 and angle 7 would be corresponding. Lower left. Angle 4 and angle 8. Good. So those would be my 4 sets of corresponding angles. Okay. Now let's try to find all of our alternate interior angles. So again, we're going from left and right set. Out of those 4, which angles fall in between the lines? Well, just 2 and 4, 5 and 7, my only interior, right? Now I need it to be alternate. So what would be the alternate interior of 2? Good, so angle 2 and angle 7. And then what would be the other set? Angle 4 and angle 5. Good. Okay. All right. Next up, alternate exterior. So now I want to focus just on the exterior, so outside of my lines. But I need them to be alternate. So my first outside, let's go with 1. What would be the alternate exterior over here? 8. Good. So angle 1 and angle 8. What's the last set? 3 and 6. Good. Alternate exterior. You see it? All right, and then our last grouping is consecutive interior. So we're back in the interior, so we're back in between, but now I need them to be on the same side. So give me one set. 2 and 5. So angle 2 and angle 5. And the other is angle 4 and angle 7. Perfect. Okay. All right, let's quickly grab a practice space, whether it's scratch paper,